Welcome back to another episode of Heavy Wireless, part of the Packet Pushers Podcast Network. My name is Keith Parsons, and today we're talking about clients and how they roam. And I've brought in an expert on doing this. Well, okay, he's done lots of expert things, but at WLPC, Jerry Olla talked about roaming wars and how clients roam differently. Jerry, how you doing today?
Hey, Keith, I'm doing great. Thanks for having me on.
So, what's the net conclusion after all of your testing and hard work in looking at clients roaming?
Yeah, so the main focus was around tri-band devices or clients specifically, and I think probably the spoiler is some clients really prefer 6 gigahertz, and some need some incentive to get them to favor 6 gigahertz if that's your goal.
Well, just to lead off and ask an easy question, a little softball here, why would you want clients to be on 6 gig?
Well, I mean, obviously, if you're deploying 6 gigahertz, that's a whole other chunk of spectrum that is probably untapped, unutilized in your space, especially in multi-tenant spaces where you might be kind of competing for that airtime with a lot of other technology and devices. So 6 gigahertz is kind of like a wide open 8-lane freeway. So we can get lots of speed, lots of performance, lots of reliability out of that band if we have the infrastructure to support 6 gigahertz as well as the devices that support 6 gigahertz.
Well, give us I know this is an audio podcast, so you're going to have to use visual words, but what was your setup for doing this testing?
Yeah, that was a tricky one. So when I decided to, or when I should say the people that voted for the presentations decided that I was going to do this topic at WLPC when it got enough votes, then I'm like, all right, now I actually have to figure out how to do all this testing.
You're not supposed to share
Yeah.
that secret. You're supposed to have them
Well,
done before.
it's one of those things where it's like, I'd really like to do this testing, but if other people aren't really interested in it, am I going to really put all the time and effort to collect all this data and parse it out and all that kind of stuff? And when, it was a highly voted topic at WLPC, I'm like, all right, I guess I got to get my butt in gear and figure out how I'm going to actually get all this data. And I had some stuff with my day job with Hamina to drive that as well, since we do some client simulations and stuff in Hamina as well. So yeah, it was easy to get motivated for that. But yeah, as far as the testing setup itself, and I started with just kind of this manual concept of take a bunch of or two APs, we'll say just two identical APs, space them far apart, maybe a big open area or something, and then walk back and forth or figure out some type of way of moving the clients back and forth between these APs to force them to have to roam, right? I realized quickly that wasn't going to be feasible with the testing I wanted to do and the number of devices I wanted to test. So I needed to come up with an automated way of kind of making these tests repeatable and not requiring a ton of walking on my part. As engineers, we're always looking for those are the lazy solutions, right? So came up with something kind of in the middle of the road there where I was able to take those two APs and instead of physically moving the device back and forth between the APs, keep the devices in a fixed location, but then take the access points and not move the APs, but actually adjust their power levels, incrementing one lower and incrementing one higher. And then that would emulate that same effect, right? It would, to the client, it looked like, oh, I'm moving away from this AP, but here I'm hearing this other AP louder and louder until finally it hits that roaming threshold and then triggers that roaming event to happen.
And that sounds like that's a way to make it repeatable and consistent.
Yep, exactly. Yeah, so that was the ticket. Took a little bit of, uh, programming, scripting, and things like that to get the APs to behave the way that I needed to and get them spaced out far enough so that way I could kind of hit those roaming thresholds and make sure it would work across the board for all the different clients. And since different clients have different roaming thresholds, so it was a little tricky. But once I got that all kind of dialed in and set up, I had a nice little roaming test rig, if you will, where I could, take a bunch of devices, iPhones, iPad, MacBook, Android devices, Windows devices, and put them all into the rig and then kind of torture test them a little bit of, forcing them to just roam over and over again. Each test I ran for an hour. And yeah, just kind of cycled through that that power adjuster on the APs. So it would trigger several roaming events, usually around 20 roaming events, depending on the client, during that course of testing, and then I would parse all the results.
So you mentioned earlier about tri-band testing. Did you start out with just a single band and the APs were on the same band changing their transmit power?
Yeah, exactly. So I started with a baseline test, or what I call a baseline test, which is, okay, I set this all up to be all things equal, other than the only variable there is different frequencies, right? So there's 3 different radios, 3 different bands, but I tried to match the RSSI side of the receive on the client side so that it heard 2.4 roughly the same as 5 gigahertz, roughly the same as 6 gigahertz, as it was changing those power levels. So that way it didn't have any incentive to go to one band or the other than, hey, this is a higher frequency. Do I prefer that higher frequency, even if I hear something else at the same RSSI value? And that was kind of my initial baseline test, just to answer the question of, do tri-band devices always prefer 6 gigahertz when there's no other incentive in the equation?
So I'm guessing you kept the SSID the same. The
Yep.
transmit power had a starting value of a different starting value depending on the frequency. So if 2.4 had X amount of power, then 5 gig would have X plus some more, and 6 gig would have some more of that. So you kept the transmit power the same. I mean, the net effect of the transmit power the same. You kept the SSID the same. You kept the channel width the same.
Yes, they were all 20 megahertz wide channels for this baseline test.
So you were trying to determine the difference between frequency. So everything else was the same but frequency.
Exactly.
And each of the 2 APs had all 3 radios turned on.
Yep. So a total of 6 options then, if you think of it that way, right? If there's two APs with tri radios, basically when you turn on the device and it goes to connect, obviously first there's that initial connection, and most of the time the clients would connect on 6 gigahertz. So kind of that initial connection. But then the question was, okay, now when this client is actually forced to make a roaming decision, it decides, okay, one, how long is it going to hang on to the connection that it has currently? And then really it has 5 other choices to make when it goes to roam, right? It could either stay with the same AP it's on, but maybe drop down to 5 gigahertz or 2.4, or it has 3 other options from another AP of 2.45, 2.45 or 6 gigahertz. And yeah, the question was, and the testing was, is where is it going to go?
Okay, now we've done the setup.
Yep.
What did you find?
So yeah, some clients, shocking to me, heavily preferred 6 gigahertz. Like they ignored everything else. When they were presented with an option of 6 gigahertz, they would connect to 6 gigahertz and they wouldn't roam until they had another good 6 gigahertz signal to roam to. And they would do that 100% of the time. They didn't care about those 2.4 or 5 gigahertz radios. The Intel, I did it with an Intel B200 and a Windows laptop running the latest version of Windows. 100% of the time, 6 to 6 every time, every roaming event. Same for the MacBook Pro. I did a M2 MacBook Pro, 100% of the time, exact same behavior, went from 6 to 6. Then all the other devices, some mobile devices, Android devices, iPhone, some MediaTek chipsets in Windows, as well as a Qualcomm chipset. They were kind of all over the place. The mobile devices seem to really heavily prefer going to 2.4. The other devices kind of just bounced around a bit more. So some devices really rock solid, really consistent, repeatable results. And then some of the other devices tended to bounce around quite a bit more.
Sounds like we're trying to reverse engineer the green diamond, the roaming algorithm. That the devices that stayed stuck on 6 gig obviously had some algorithm that said, if 6, then choose, and then just stop there. Others had obviously other things going on. So could you manipulate your testing rig, say, to get rid of the 2.4 radio at all, to see if it then would adjust between 5 and 6?
Yes. Yeah, I did run that test, took the same kind of configuration, just turned off the 2.4 radio and said, okay, let's just remove one of those options, right? So instead of having 6 options, now it only has 4 options. So let's see if we just kind of remove that from the equation. Does it make some better choices? Surprisingly to me, it didn't really seem to make better choices in the sense of all it did was take at least the mobile devices that were more preferring 2.4 initially, just started to kind of evenly roam between 6 and 5 gigahertz now. So by taking away the 2.4 option, they didn't seem to prefer 6 gigahertz necessarily much more, a little bit more, but they seem to just kind of bounce between 5 and 6 gigahertz then.
It sounds like there could be some additional testing to find out, was the 2.4 actually being chosen because it was 2.4, or because maybe you messed up a little bit on the conversion rate? That was it, I don't know. Did you set like a 6 dB differential between 2 and 6 or 2 and
I
5?
did, yeah, exactly. So I clamped I had to put a clamp in there for 2.4, so that 2.4, as these power level adjustments were going, it clamped the 2.4 to always be 6 dB less than the 5 and 6 gigahertz radios.
But even with that, it still chose it.
It still would go over to 2.4 when there wasn't any other incentive, right? Now we're just talking about all things kind of equal from a channel width standpoint, right? Just frequency is the only variable here. And without any additional incentive, the clients weren't really incentivized to go band preference wise to 6 gigahertz.
Well, one of the things we know based on some of the vendors' documentation, that by having wider channels, it might choose that instead. And I think it's kind of a placeholder for faster data rates.
Yes. Yeah,
So,
there is multiple documentation. There's documentation for both, Android and Apple, which talks about both for iOS and macOS, that they do have in their algorithms of the roaming candidates that it will favor wider channels. So if it does hear a different radio than what it's connected to at a wider channel, or if it hears multiple options and one of those options is a wider channel or a higher data rate, it does some throughput calculations. But yes, obviously data channel width is going to drive that data rate factor the most. So yes, if it does, so that was another test that was ran was, okay, well, let's just adjust one variable here with everything else being the same. What if we just bump up the channel width on one of these bands? So starting with 6 gigahertz, if we just increase that channel width from 20 to 40 or 20 to 80, does that impact the client's decision?
survey shows.
Survey shows drastically it does. Yeah. So really that was the biggest mover of these clients got sucked to 6 gigahertz like a magnet as soon as I increased that channel width. So going from, anything over those other bands. So obviously 2.4, we're kind of limited or restricted to 20 megahertz wide channels. 5
Hopefully.
gigahertz, we can go, yeah, hopefully.
Hopefully.
5 gigahertz, we can use, some 40s and maybe some 80s in there. But on 6 gigahertz, we could technically go all the way up to 320 megahertz. Not that that's recommended either, but even using something like 40 or 80 megahertz wide channels on 6 gigahertz really sucks those clients to using a wider or using a higher frequency, in this case 6 gigahertz, by just having that channel width preference.
Well, for our friends who don't happen to live in North America or someplace with our 1200 megahertz of 6 gig, did you see that the 40 megahertz had as much impact as the 80?
Yes, it did seem like it. So when you compare of like, let's say with 2.4 and 5 gigahertz being at 20 megahertz and just bumping up the 6 gigahertz to 40 megahertz, just that wider channel width being there and presenting itself, that would have the same impact of if we also did an 80 megahertz channel on 6 gigahertz just by having that wider. Now, I did also run a test of 5 gigahertz being at 40 megahertz and 80 being at 6 gigahertz being at 80 megahertz. And then we still did see some clients still being okay with going to 5 gigahertz when there was a wide channel option on 5 gigahertz, obviously over 2.4. So just by having any type of increased channel width over 20 megahertz seems to draw those clients into those channels. But ultimately, yes, they would majoritively favor that 6 gigahertz band if it was the wider channel over 2.4 and 5.
So the conclusion you can draw from that is if we want to incent devices to go to a place, we can make wider channels.
Yes, exactly. From my testing, that was probably the one biggest factor. If you want to get your clients to go to a specific band, put that band as a wider channel than any of the other bands, and you're going to see a significant amount more traffic or clients associations on that particular band. Obviously, if those clients support that band is the big piece of that equation as well. But yes, if you do have tri-band capable clients that support 6 gigahertz, I definitely recommend using a wider channel width on 6 gigahertz if your goal is to get them to actually use that 6 gigahertz radio.
I guess this is backing up a little bit, but back on the baseline, what were you running for 6 gig discovery?
So this would have been using R&Rs. So it was, essentially able to discover, the clients seemed to be discovering the 6 gigahertz radios primarily out of band, where they would hear the beacons on like 2.4 and 5 gigahertz, and that's how they would discover 6 gigahertz. I did run a test using Phil's discovery, which means I disabled the 2.4 and 5 gigahertz and only use 6 gigahertz. And for the most part, most clients work perfectly fine with the Phil's discovery, but they did seem to struggle to roam in the sense that they would find the 6 gigahertz, everybody would connect up to it, but when it was time to roam, we saw much fewer roams from some of the clients. So they did seem to struggle on the roaming side. So often we talk about, the Phil's discovery of like, can these clients find 6 gigahertz? Didn't see any problem there. They would initially connect up to 6 gigahertz, but then when it came time to roam, some clients did all right with that, and other clients seemed to become very sticky and kind of hang on to that 6 gigahertz radio much longer.
Well, and Phil's isn't a great solution anyway, for other reasons as well. But just one more thing to leave R&R guys on, folks.
Yep.
Now, I don't know about 2.4, but I would lean more towards 5 gig R&R fulfills the needs. Any other conclusions after pulling all this data and you presented it? What would you say is your main takeaway from all of this data testing?
Main takeaway, 802.11k was an interesting one to me. I've always had that question in the back of my mind when we talk about 802.11k is, what do the clients actually do with these neighbor reports that's part of 11k? And we talk about, we can see the neighbor reports that get sent up from the APs, all that kind of stuff. But I've never seen any kind of factual data of like, okay, this actually improves the client experience and here's the results before and after. So I was able to do a test with that of just, running the same roaming test without 11k and with. And for at least for the iPhone, we saw significantly improved behavior from the iPhone, where it roamed more, what I would say kind of more aggressively, or in other words, less sticky, right? It hung onto the AP less. It would actually roam more frequently and faster. It would find a new AP, and it would make a better decision, in my opinion, of it would prefer 6 gigahertz and find 6 gigahertz much more in its roam. So it seems like 11k could be very impactful for specific devices, in particular the iOS devices in your environment.
Well, years ago, there was some complaints or worries that some clients weren't happy with K. So you found the iOS devices did better. Did any device do worse with K on?
Yeah, great question. Yeah, that's a good point. The other side of it, I was really happy with when I enabled 11k, I saw no difference in performance from the other clients that were already performing well without 11k. They actually performed identically. So it didn't seem to have any negative effects, at least with the devices I test, which were all very modern, Wi-Fi 6 capable, or Wi-Fi 6E, Wi-Fi 7 capable devices. So at least for these modern clients, they seem like either they don't do anything with that information and they just use other information they already have to make good decisions, or it just kind of helps them that much more to make better decisions.
Anything with V and R then?
So V was enabled by default. So that was one of the things I also kind of did with this testing is I left everything that is normally on by default. in place. And then I just kind of toggled on different options that were not normally turned on by default to see what kind of impact this has. So in the environment that I was using, K was not enabled by default. So I first tested it without K, and then I tested it with K enabled to see how that would impact things. But yes, V was enabled. I didn't test R. That was not enabled, but I didn't think or wouldn't expect that would have any impact on the roaming decisions, because that kind of happens after the client has already made its roaming decision. But yeah, it would be maybe worth doing some testing with that, since it should technically speed up the roaming time a little bit.
Just another baseline question. Were you running PSKs or open or .1x?
Yeah, all PSK, and obviously WPA3, since we're using 6 gigahertz. So my options would have been, using OWE or WPA3. So I just did, to keep things kind of simple and make sure everything was compatible, just WPA3 PSK.
Okay. If you had one takeaway, so people have been listening to this for the last 20 minutes, what's your recommendation on how to set up your network to get the most clients go to 6 gig most of the time?
I think the number one thing out of the testing was wider channels. If you're thinking about deploying all 20 megahertz wide channels, and maybe you're restricted for various reasons, depending on your location in the world and how much 6 gigahertz bandwidth you have, you might be a little more restrictive on this. But if you can use a wider channel on 6 gigahertz, that's going to be your biggest kind of magnet, if you will, to sucking those clients over to the 6 gigahertz band. It seems like, as soon as you flip on, a 40 megahertz channel or an 80 megahertz channel, while keeping your 2.4 and 5 gigahertz at a narrower channel, you should definitely see a lot more clients favoring that 6 gigahertz band if they're able to.
Well, Jerry, thanks for your time and for obviously hours and hours spent testing. I'm assuming you have many days of your life in that test rig. If someone wanted to track you down and find you, how would they find you on the internet?
Either on X or LinkedIn, just at JOLLA, or find me as under Jerry Olla on LinkedIn.
Great. Well, thanks for the time. And you've been listening to another episode of Heavy Wireless, part of the Packet Pushers Podcast Network. If you have any questions on this, feel free to add comments in the show notes. In the show notes, we'll also add links to find Jerry, as well as a YouTube video of his presentation on this very topic at WLPC in Phoenix from February 2025. Thank you for listening, and we'll catch up with you on the next episode.